Okay, this is 4.5 notes using completing the square to convert to vertex form. Okay, so off to the left we have what completing the square is. If we were to express this in words, it means to complete the square for the expression x squared plus bx by adding half of b squared. If we were to look at the diagrams, in each diagram, the combined area of the shaded regions is x squared plus bx. If we were to add half of b squared to both sides, it would complete the square in the second diagram. Okay. If we were to think of it algebraically, we have the equation x squared plus bx plus half b squared is equal to x plus half b times x plus half b, which is equal to x plus half b squared. Okay. So in the first example here, it says determine the value of c in the trinomial x squared plus 14x plus c so that it's a perfect square. Okay. The formula here, c is equal to half b squared, is the only formula that we need to memorize for this section. Okay. And we are going to follow this formula in order to find that missing c value. So our b value for this equation is that 14. So I'm going to write 14 divided by 2 squared. 14 divided by 2 is 7, and 7 squared is 49, which means we could write this as x squared plus 14x plus 49. But since we're trying to turn it into a perfect squared trinomial, we're going to take the number right before we square it, so that number 7, and we're going to write this as x plus 7 squared. Okay. What this means is that another way to write x squared plus 14x plus 49 is x plus 7 squared. Okay, so that was how to find the c value. Now we're going to look at examples on how to convert standard form into vertex form by completing the square. So we need to use that formula for c in order to do this, but we also have to follow the other steps on the left side. So our first step here says move the constants to the other side of the equation. Remember, the constants are going to be the numbers that do not have a variable. So in example 2, our constant is -6. So we are going to move -6 to the other side of our equation and get y plus 6 is equal to x squared minus 4x. Okay, so everything we just did here follows example 1. Step 1. Step 2 says if a is not equal to 1, divide the entire equation by a. Well, our a value here is equal to 1, so we can skip that step. Then it says find the new c value to create the perfect square using the equation c is equal to half b squared. So off to the side and say c is equal to parentheses -4 divided by 2 squared, which is equal to -2 squared, which is equal to 4. Okay, so this step here is step 3, and I'm color coding it so you can see where the steps are going. Okay, step 4 says we're going to add that new c to both sides of the equations. So our c value was 4, so I'm going to add 4 to both sides, and I get y plus 10 is equal to x squared minus 4x plus 4. This is my step 4. Okay. Then we're going to convert that trinomial into a perfect square. That is step 5. Okay, so we're converting this into a perfect square. And we do that by focusing on the number right before we square it, and that was that -2. So I'm going to write this as y plus 10 is equal to x minus 2 squared. And I got that -2 from the -2 that I circled from step 3. Okay. And then my last step says to solve for y. So in order to solve for y, I need to subtract 10 to the other side. And then I get y is equal to x minus 2 squared minus 10. That is that step 6. Okay. So I can write that answer on the line that says vertex form. So y is equal to x minus 2 squared minus 10. The vertex here we know is HK, and we know that the H value is always opposite. So since we see a -2, our H value is going to be a +2, and then the K value is -10. So we have 2, -10. Then if you look off to the side again where it says step 7, it tells us whether our parabola is going to be opening up or down, and that is based on whether A is positive or negative. Well, since our A value is 1 and 1 is positive, our parabola is opening up. Okay. We're going to do the same steps for example 3. So our first step is to move the constant to the other side. So we're going to subtract 12 to the other side. I get y minus 12 is equal to 6x squared plus 12x. Our next step says if our a value is not 1, we have to divide everything by our a value. Well, since our a value here is 6, I'm going to divide everything by 6. So I have 6y minus 2 is equal to x squared plus 2x. My next step is to find my c value. So c is equal to b over 2 squared. My b value is 2, so this is 2 over 2 squared, which is 1 squared, which is 1. I'm going to add 1 to both sides, and I get 6y minus 1 is equal to x squared plus 2x plus 1. Then I'm going to convert my trinomial into that perfect square by using the number right before I square it. So in that case, that's the 1. So I have 6y minus 1 is equal to parentheses x plus 1 squared. And then my last step is to get y by itself. So I'm going to first add 1 to both sides, and I get 6y is equal to x plus 1 squared plus 1. And then in order to get rid of that 6, I'm going to multiply both sides by the reciprocal 6. So I'm multiplying both sides by 6. And I get y is equal to 6 parentheses x plus 1 squared plus 6. And that is my answer that I'm going to write on the line where it says vertex form. And my vertex is always my opposite h value. So instead of +1, I'm going to write -1 and then comma 6. And since 6 is my a value and my a value is positive, I know that my parabola is opening up. Example 4. First, I need to move over my constant, so I'm going to add 4 to the other side. I could rewrite f of x as y to make it easier on us. So I can say y plus 4 is equal to 3x squared plus 9x. My a value is 3, which means I have to divide everything by 3. So I get 1/3 y plus 4/3 is equal to x squared plus 3x. Okay. Then I have to find my c value. So c is equal to 3/2 squared, which is the same as saying 3 squared over 2 squared, which is 9/4. So I'm going to add 9/4 to both sides, and I get 1/3 y. And then in order to combine these two fractions, be able to add them together, I need a common denominator. So between 4 and 3, that common denominator is going to be 12. So I'm going to multiply this one by 3 and this one by 4. Okay. Which means I get 27/12 plus 16/12, which is 43/12 is equal to x squared plus 3x plus 9/4. Then I have to turn my trinomial into a perfect square by taking the number right before it gets squared. So in this case, that is going to be the 3/2. So I'm going to write 1/3 y plus 43/12 is equal to parentheses x plus 3/2 squared. Then I'm going to subtract the 43/12 to the other side because I'm trying to get y by itself. So 1/3 y is equal to x plus 3/2 squared minus 43/12. And then my last step is to get y by itself by multiplying both sides by the reciprocal of 1/3, which is 3. And I get y is equal to 3 parentheses x plus 3/2 squared. And then if I'm multiplying that negative 43/12 by 3, that's the same as multiplying it by 3/1. And when we're multiplying fractions, there's a property that says we can reduce on the diagonal. So 12 and 3 can both be reduced by 3, so this turns to 1 and this turns to 4, which means I have a negative 43/4 after I multiply it by 3. So this is my answer that I'm writing on the vertex form line. So y is equal to 3 parentheses x plus 3/2 squared minus 43/4. My vertex is going to be negative 3/2 comma negative 43/4. And since my a value is 3 and 3 is positive, it's going to be opening up. Okay. Last example here is a real world problem. So it says, while marching, a drum major tosses a baton into the air and catches it. The height h and feet of the baton t seconds after it is thrown can be modeled by the function h of t is equal to negative 16t squared plus 64t plus 6. Okay, so I'm going to take that equation and I'm going to turn this into vertex form by completing the square. So I'm first going to subtract the constant over, and I get h of t minus 6 is equal to negative 16t squared plus 64t. Then I'm going to divide everything by negative 16 since that is my a value. And I get negative 1 over 16 h of t plus 3/8. Negative divided by a negative is a positive. 6/16 reduces to 3/8 is equal to t squared minus 4t. I'm then going to find my new c value using the formula b over 2 squared. So this is going to be negative 4 over 2 squared, which is negative 2 squared, which is 4. So I'm going to add 4 to both sides. In order to add the 4 to the 3/8, I need it to have the common denominator 8. So I'm going to multiply top and bottom by 8. So I get 32/8 plus 3/8. So I'm left with negative 1/16 h of t plus 35/8 is equal to t squared minus 4t plus 4. Turning this into a perfect squared trinomial, I always use the number right before I square it, so that's going to be negative 2. Excuse me. So this becomes negative 1/16 h of t plus 35/8 is equal to t minus 2 squared. I'm going to subtract the 35/8 to the other side, and I get negative 1/16 h of t is equal to t minus 2 squared minus 35/8. And then in order to get rid of that negative 1/16, I'm going to multiply both sides by the reciprocal, which is negative 16. So I'm left with h of t is equal to negative 16 t minus 2 squared. And if I'm multiplying these two fractions, that's the same as saying negative 16 over 1, which means I can reduce on the diagonal by 8. So this becomes 1 and this becomes negative 2. So I have negative 35 times negative 2, which is positive 70. So that's my equation in vertex form, which means my vertex is 2, 70. But remember, our real-world problem was in t, h of t, which means this is seconds and this is feet. Now to answer the last two questions, it says, what is the maximum height of the baton? Well, the maximum height would be h of t, which is 70, so 70 feet. And at what time did the baton reach its maximum height? That would be the t value of 2, so 2 seconds.